Hi everyone, welcome to another maths video by Maths with Sarah. So today we're going to be taking a look at this question that looks at two similar cones. We've been given the volume of each of the cones and the ratio between the two volumes, and we've been given one of the surface area. And the aim is to calculate the surface area of the second cone. So somewhat seems straightforward, but obviously there are some twists in here. So what I'd quite like you to do is, as with all of these videos, I'd encourage you to pause the video around about now, have a think about how you will go about solving this yourself. Even if you get stuck, don't worry, I'm going to go through it in a second. And then when you're done, come back and have a look and see whether or not we've used the same method. Okay. So the key point of this one is that we've been given the ratio of the volumes. So we haven't been given the ratio of the surface area. That will make it a little bit easier. We've been given the ratio instead of the two volumes. So what we need to remember is that the scale factor for the volume is the cube of the length, and then the square, it will be squared to find out the area. So there's quite an easy way of remembering this, because this is something that, we've got two values here that are quite clearly can be cube rooted, which obviously cube numbers, which obviously helps to give us a little clue about what we need to do. But we can also use the units to help us out as well. So for example, here we have centimeters cubed will be the ratio of the volume. And this is 27 to 8 for A and B. If we're then trying to work out the surface area, we know that the surface area will be measured in centimeters squared. So the same, we need to square the scale factor. And if we're just looking at a length, then that would just be measured in centimeters. So again, we'd have to cube root, or we'd have to cube it if we were going in the opposite direction. So for this set, I would encourage you to work out fill in all the missing gaps. The way that I find it easiest is to go from the volume as being 27, and then use that to work out what the scale factor is for length, and then you can square that to work out what the scale factor is for the surface area. This is the way that I think it's easiest, but it's up to you how you do it. So if we were to cube root 27, we'd end up with 3. And like I said, with the units, this is the cube, this has got no units. This one, if we cube root 8, we get 2. So now what we can do is we can say, well, we know that the scale factors for just the lengths on their own is 3 to 2. So if we square both of those, we're going to get the scale factors that we can use to work out the surface area, which is obviously what this question is actually asking us to do. So now we have got a value of, we know that the scale factor to calculate the surface area is 9 to 4. And we know that the surface area of cone A is 297. So from there, we just need to work out what the surface area of cone B is. So hopefully you're familiar with using scale factors. The way that I would do this would be to divide by this one. So essentially we end up with a net of 1, and then times that by 4 to calculate what. So we're going to divide to get to this one. So divide by 9 to get to that one. That will essentially give us 1, and then we'll times by 4. So when we do all of that, we end up with 132 for this box here, which is of course exactly what we've been told to show that it is. So very nicely, it has actually come out as the right answer. Always a good way of checking that you've done the right maths. So the main point from this question, I think the thing that makes it most difficult is that we've been given the scale factor of the volume, and we need to work out the area. So it's all about just remembering that you can't use this as your scale factor directly for area. You've got to do something to it first. So in this case, cube root it and then square it in order to, or do a factor of 3 to 2, 3 over 2 would also work. 2 over 3 would also work. But yeah, essentially the most important thing is that you remember that you need to deal with the scale factor before you can start looking at the surface area. So I've got lots of new videos coming out. I'd really appreciate it if you could like and subscribe to this video, or subscribe to my channel, so that you find out straight away as soon as any new videos come out. Thanks for watching.